Good morning. My name is Aravindh. I'm just working as assistant professor in the Department of Computer Science and Engineering. Today we are going to see about the data link layer protocols. Uh, Before that, we just want to see what are the different services provided by the data link layer. First, the data link layer recover the services from the physical layer, and then it gives the services to the network layer. Basically, in the case of the physical layer, the collection of the raw bits, that is, combinations of zeros and ones, will be transmitted from the source machine to the destination machine by using the physical address. So the collection of zeros and ones is called as data frames. So this data frames can be transmitted from the source machine to the destination machine by using an addressing called as MAC address, that is a media access control address. And then in the case of the data link layer, there are several duties and responsibilities of the data link layer. The first one is the error control. First, um, before we are just going to send the data from the source machine to the destination machine, first we have to check for the error. There are different types of error in the case of the data link layer. One is a burst error and another one is a single bit error. And then in the case of the error control, we also discuss about the error correction and error detection technology. After that, in the case of the addressing, we are just using the addressing called as media access control. And then these services will be, it gives the services to the network layer, which is the next layer in the case of the OSI reference model. It gives the services to the network layer. So in the case of the data link layer, the flow control, error control, addressing, and packetization are the main duties in the case of the data link layer. So in the case of the data link layer, we are having different types of protocols. So a protocol is nothing but it is a set of rules to govern a network is called as a protocol. A protocol is nothing but it's a set of rules to govern your network is called as a protocol. So in the case of a protocol, we just see different types of protocols. In the case of a network layer, we are going to see about IP, that is internet protocol. And in the case of a transport layer, we discuss about TCP and UDP, that is a transmission control protocol, user datagram protocol. And then in the case of your application layer, DNS, Telnet, DHCP, and then SMTP, or the different protocols we just studied. And in the case of a data link layer, we are going to see about 4 different types of protocol. The protocol will be subdivided into noiseless channel, and another one is the noisy channel. First one is a noiseless channel and another one is your noisy channel. So in the case of a noiseless channel, we are having 2 different types. One is the simplest and another one is the stop and wait protocol. In the case of a noisy channel, we are having 3 different types of protocol. One is your stop and wait protocol, go back NARP protocol, and then the selective repeat protocol. Generally, in the case of a data link layer, we just going to discuss about 4 different types of protocol. One is your stop and wait protocol, go back NARQ protocol, selective repeat ARQ protocol, and then your sliding window protocol. So these are the basically 4 different types of protocol we are going to discuss in the case of your data link protocols. First one is a noiseless channel protocol. Is first we discuss about the simplest category one, that is the simplest protocol. Next we discuss about the stop and wait protocol. So in the case of the data transmission, first we just need a sender machine, receiver machine, and then I need a timer, right? And then your message. Then we are going to transmit the data using a wired communication or a wireless communication. First one, I need a sender machine. Next one is a receiver or the destination machine. In the case of a destination machine, we just want to check whether the destination mission has the capability to receive the data from the sender mission. And then in the case of a sender mission, will have a memory called as buffer memory. What is the use of this buffer means the data, a copy of the data will be saved in the case of the buffer memory. Why do you need a copy of the data means during the data transmission, if there is any, yeah, the data will lost at that time, I just want to retransmit the data or I just want to resend the data. That is the main use of your, you just want to keep the copy of the data in the case of your buffer memory. And then during the data transmission, my timer will, I just want to on my timer. Why I just want to on my timer means, you just imagine I'm going to send a data frame from a source mission to a destination mission. The time taken to transmit or migrate the data frame from the source mission to the destination mission will be around some microsecond. You just imagine a 3 microsecond to transmit the data from the source machine to the destination machine. But in the case I'm just sending the data, the timer will be on. You just imagine 10 microsecond or 15 microsecond, the time exit means there will be no acknowledgement received from the receiver machine to the sender machine means for that purpose I need a timer. I just need a timer to transmit the data from the source machine to the destination machine. So first one, I'm just sending a frame. It's a simplest protocol. It's a very simple protocol. The sender sends a sequence of frame without thinking about the receiver. So the receiver, the sender doesn't know whether the receiver had received the data or not. So in the case of the simplest protocol, I'm just sender n number of frames. That is a sequence of frame from the source to the destination. The data are transmitted during this data transmission in the case of the simplest protocol. In the sense, the data will be transmitted in only in one direction. The data will be transmitted only in one direction. So the data will be transmitted in only in one direction. Both sender and receiver is always ready. So in this case, the sender and receiver both is always ready. The timer will be on. The processing time will be ignored. Indefinite buffer space is available. So I'm just having so many space in the buffer in the case of your sender mission. So it will travel in only in one direction. N number of frames can be transmitted at a time without thinking about the receiver or the destination mission. The next, in the case of the noiseless channel, the next protocol will be the stop and wait protocol. Stop and wait protocol. This protocol is also, the data transmission is very simple. The sender sends one frame. In the case of the simplest protocol, the sender sends n number of frames. It doesn't consider about the receiver or the destination machine. But in the case of a stop and wait protocol, I send a single frame. It waits for the feedback from the receiver or the destination machine. It will wait for the acknowledgement. It waits for the acknowledgement. For example, the receiver machine sends a request to the sender machine. I just send a frame. I just sent a frame. After I sent a frame, the receiver will send a acknowledgement. The receiver will send a acknowledgement to the sender. After that, the frame 2 will be sent from the sender. Acknowledgement 1 will be received from the receiver. Likewise, sender sends the frame to the receiver. After getting the acknowledgement, again it will send a frame. Likewise, after getting the acknowledgement, again the next frame will be sent. So it's a very simplest protocol. It will send one frame at a time. After getting the acknowledgement for the same, it will send the next frame. So in the case of a stop and wait protocol, the sender sends one frame. If the receiver gets the acknowledgement and receives the confirmation from the sender, it will send the next frame. That is, it sends one frame. After getting the acknowledgement, it will send another frame. So it's called as a stop and wait. Stop and wait protocol. And next one is the noisy channel. Now we discuss with the noiseless channel. One is the simplest protocol and another one is your stop and wait protocol. Next one is your noisy channel. That is your sliding window protocol. Sliding window protocol. Three different types: stop and wait, go back in, selective repeat protocol. So there are three different types of protocols: stop and wait protocol, go back in, automatic repeat request, and next one is your selective repeat automatic repeat request protocol. First one is your stop and wait automatic repeat request protocol. In this, we just want to add some redundant bit with the data. We just want to add the redundant bit with the data. Then and then after adding the redundant bit, I am just send the frame from the source machine to the destination machine. So the destination machine checked the frame. If it doesn't receive the frame, it considered as a lost in frame. So it doesn't send acknowledgement to the source machine. So it considered this as a lost in frame. And then a duplicate frame or a copy of the frame is again sent to the receiver machine or the destination machine. Receiver machine or the destination machine. That duplicate frame or a copy of the frame will be saved in the case of the buffer memory. So in the case of the destination, in the case of your stop and wait automatic repeat request protocol, first I just send this data frame with the redundant bit from the source to the destination. From the source to the destination, both in the case of your sender and the receiver, the timer will be on. You just imagine within some microsecond, the data frame with the redundant bit has to be sent to the sender machine to the destination machine. But in the case of the receiver machine or destination machine doesn't receive the data frames from the sender machine. So I just want to resend the frame because no acknowledgement has been received from the sender machine to the receiver machine. At that time, I just want to send a copy of the frame or a duplicate frame, which has been stored in the case of your buffer memory in the sender machine. After getting the frame, it will send an acknowledgement to the sender machine. If the receiver does not, if the receiver doesn't respond for any acknowledgement, means again I just want to resend the frame. After getting the receiver machine will send a copy of the acknowledgement to the sender machine. You just take this diagram as an example. So SN means is nothing but S is the sender and R is the receiver. SN means the number of bits we are going to transmit from the source to the destination. First, after getting the request, I'm just sending frame 0 from the source machine to the destination machine. Frame 0 from the source machine to the destination machine. The receiver machine received frame 0. The receiver machine receives the data frame 0 without any collision or without any delay. The timer in the case of the sender and the receiver will be on. So without any delay, the receiver has received the frame 0. So at that time, I just want to send an acknowledgement for this ACK1. The receiver sends an acknowledgement that is ACK1 to the sender. After that, I'm going to send frame 1 from the sender machine to the receiver machine. Due to some error, the frame 1 not reach the destination or receiver machine due to some data transmission error or something like that. At that time, I just want to keep the copy of the frame 1 or the duplicate frame 1 copy in the sender machine buffer memory. Again, the frame 1 has been resent. Again, the frame 1 has been resent because the previous frame 1 will, due to some data transmission error, the frame 1 has been lost. So again, I just want to resend the frame. After receiving the frame 1, the receiver machine sends an acknowledgement called as ACK0. The receiver machine sends an acknowledgement called as ACK0. Next, again, after receiving the acknowledgement 0, the sender machine sends frame 0. Next frame. First one is your frame 0. Next one is your frame 1. And next one is your frame 0 has been sent. The receiver machine received the frame 0. The receiver machine received the frame 0. But after receiving the frame 0, it has the destination has a duty to send the acknowledgement. That is the ACK1 to the sender machine. ACK1 to the sender machine. But due to some error, the acknowledgement has not been received to acknowledgement 1, not yet received to the sender machine. So there will be lost in the acknowledgement. So there will be some lost in the acknowledgement. Again, I just want to send the frame 0. Again, I just want to send the frame 0. So I just want to resend the frame. Resend the frame 0. I just add a copy or a duplicate copy of your frame 0 in my buffer memory. So after resending the frame 0, the receiver receives successfully and it sends the acknowledgement. The first loss in this data transmission, the first loss will be in the frame 1 has been lost. And then finally, the acknowledgement has been lost. ACK1 has been lost. So if there is the lost in frame or lost in acknowledgement, again, we just want to retransmit the frame. So the next one is your go back n automatic repeat. The next one is your go back n automatic repeat request. So to improve the efficiency of transmission, in the case of your stop and wait, at the same time, I can able to transmit a single frame after getting the acknowledgement since another frame. But in the case of a go back, here multiple frames can be transmitted from the source to the destination. So I can able to send a number of frames at the same time. For example, I can able to transmit 3 to 4 frames at a time. You just imagine. I can able to transmit 3 to 4 frames at a time, but I want to get a single acknowledgement for the 3 to 4 frames. So in the case of your go back, at the same time, I can able to send multiple frames at a time. But I just want to confirm whether the receiver machine is ready for data transmission or it is busy with some other work or so in the case of your go back n automatic repeat, I can able to transmit n number of frames at a time, but I can able to receive only a single acknowledgement. So several frames can be transmitted in the case of your go back and automatic repeat request. You just see the diagram. Here we are having the go back the sequence number or modulo 2m. where m is the size of the field bits or the size of the frame. And it will be ranges from 0 to 2, and the power will be m minus 1. For example, you just imagine the m is 4 means m power 4 16, so it ranges from 0 to 15, that is 16 bits. So SF is the first outcoming frame, SN will be the last frame. So you just imagine frame in the orange color. So you are just going to send 7 frames at a time. So 7 frames at a time. So the formula will be 2 power m minus 1. So 2 power m minus 1 is nothing but you just imagine m will be the 4 means 2 power m is 16 minus 1. So that will be 50. So so here the go back and automatic repeat request. First, you just imagine SF is the first frame, SN will be the last frame. So here the multiple frames can be sent. First, frame 0 has been sent. A single frame has been sent, ACK1. I get received, ACK1. Next, 1, 2, 3. Frame 1, 2, 3, I sent. Frame 1, 2, 3, I sent. But the acknowledgement for frame 1 not yet received in the case of your destination. Acknowledgement. So it's an example for your lost in acknowledgement. So if there is any lost in acknowledgement, or if there is any lost in the frame also, again I just want to resend the frame only. So here I sent frame 1, frame 2, frame 3. For that, I just want to receive acknowledgement 2, acknowledgement 3, acknowledgement 4. But there is some delay in the case of your ACK2. Again, so you just imagine there is a lost in the acknowledgement 2. Again, I just want to send frame 1, frame 2, frame 3. If it receives successfully, the receiver machine will send ACK2, ACK3, ACK4. This is another example. Already the timer is set. I just sent 5 frames, frame 0, frame 1, frame 2, frame 3, frame 4, 5 frames I sent. So I just want to receive ACK0, ACK1, ACK2, ACK3, ACK4. But here, yes, there will be, I just received ACK0 and ACK1 successfully. ACK2 for frame 2 doesn't receive it receive from the receiver machine to the sender. At that time, I just want to retransmit which frames 0 and 1 are successful. So again, I just want to retransmit frame 2, frame 3, frame 4. After that, the successful transmission, I got frame 2, frame 3, frame 4 acknowledged. Right. Next one is where selective repeat automatic request. This is also the noisy protocol. So here the diagram represent SF. SF is nothing but the it's first frame we are going to send, and next SN will be the last frame. And here we just want to send set the size of the window. In the case of a sliding window, we just set some size. Here in the diagram 13, 14, 15 frames already acknowledged and sent and acknowledged. 0, 1, 2, 3 and 3 we are going to send and not yet acknowledgement. If we send, we get the acknowledgement. And next 4, 5, 6, 7 frame that can be sent, going to send. Next 8 to 15 and then 0 frame cannot be sent. First one is center window. In the case of your center window, we just want to see before sliding and after sliding. In the case of a receiver window, the same formula, that is the 2m minus 1. Same as in the case of your go back N protocol. You just see. So here I am going to send 4 frames 0, 1, 2, and 3, right? So we just sent the sliding window. First I sent frame 0 from the source machine to the destination machine. I just sent frame 0. After the receiver machine, that is a B, received the frame 0, it automatically receives the acknowledgement. It sends the acknowledgement to the sender, that is the ACK1. ACK1. So frame 0 has been successfully sent. After that, I just want to send frame 1, frame 2, frame 3. So the size of the window will be 4. The frame 0 had already I just sent. Next frame 1, frame 2, frame 3 I just sent. The receiver machine frame 2 and frame 3 successfully received, but there will have some loss in the during the data transmission of frame 1. So there will be lost in frame. Lost in frame. Again, I'm going to ask a question whether the acknowledgement for frame 1 and frame 2 we will receive from the receiver machine to the sender means no. It will send a negative acknowledgement. After sending, again, I just want to send the frame 1. After getting the frame 1, it will send an acknowledgement for all the frames. That is acknowledgement 4. That is the acknowledgement 4. So these are the 3 different protocols we just discussed in the case of your data link layer elementary protocol. We have a quick lookup of this session. First, we just seen about the different duties of your data link layer. The data link layer receives the services from the physical layer and gives the services to the network layer. The different duties of the data link layer are packetization, flow control, error control, and addressing. So in the case of a data link layer, collection of data frames has been transmitted from the source machine to the destination machine by using an address called as media access control addressing. Next, 2 different types of protocol, noiseless channel and another one is your noisy channel. In the case of your noiseless channel, simplest one and another one is a stop and wait protocol. In the case of your noisy one, stop and wait ARQ, go back and ARQ, selective repeat ARQ. In the case of your simplest protocol, we can, without thinking about the receiver, we are going to send n number of frames. There will be no acknowledgement. So the data will be transmitted in only in one direction. Next one is your stop and wait protocol. Here the transmission takes place. When I just send a frame means I need a feedback or acknowledgement. After getting the acknowledgement, I send a next frame. This is an example for a stop and wait protocol. Next, the noisy protocol, stop and wait automatic request, repeat request, go back and automatic repeat request, selective repeat request. Here we can send a frame after getting the acknowledgement. So we can send the n number of frames at a time. But I just want to receive the acknowledgement from each and every frame from the source machine to the destination machine in the case of your stop and wait elementary protocol. So the next one is where we just want to set the window size. Here we can send the n number of frames, but in the case of stop and wait, I can able to send a single frame, but here we can send the n number of frames at a time. So after getting the acknowledgement, we can able to send another frame without getting the acknowledgement. That means again, I just want to retransmit the frame. Here also, we just want to set the window size. After setting the window size, n number of frames can be sent from the source to the destination machine. If there is any lost in frame, or lost in acknowledgement means a negative acknowledgement. It will generate after getting the negative acknowledgement. Again, I just want to send the lost frame in the case of your selective repeat and ARQ. So these are some of the data link layer elementary protocols we discussed. So in this session, we just discussed three different types of protocols: stop and wait protocol, go back and ARQ protocol, and then the selective repeat ARQ protocol. Here, the services from the data link layer, it gives the services to the network layer. In the case of a network layer, it will transmit a collection of data frames into some data packets. It will transmit from the source to the destination mission by using a addressing called as IP address. Thank you, students.